So we can increase them into 2 or 4. Okay. If we deploy 4 I/O servers, it will cost a lot of money since the I/O servers did not take part into the computing process. So the ratio of the compute instances and the I/O instances should be chosen carefully. We can also deploy the PVFS I/O servers into part-time I/O servers. Okay, this is an example of results showing the options of the sync mode and the device. Since we can use EBS and the ephemeral disks, this picture shows that there are no obvious performance difference between those two kinds of disks. But for the small block size, 16 megabyte and 112 megabytes, the async mode can provide the async mode prefers small block sizes. The NFS server can provide much higher bandwidth for small block sizes. This picture shows the NFS write bandwidth when we want to mounting many EBS disks into a software real. And from this picture, we can say that the real zero, that balance is still very well. We can also increase the number as many as we want because the two ephemeral EBS disks can separate the I/O bandwidth. Possibly because the virtualized layer. And I will show some preliminary application results next. This picture is the BTIO results. BTIO is the I/O-enabled version of the BT benchmark from the MPP suite. And the class is the end, subtype is 4. So we explore the MPI/O interface to run. And from this picture, we have many configurations, including the NFS dedicated, NFS part-time, and one PVFS I/O server, 2 dedicated PVFS I/O server, and 4. And also we configured about 4 I/O server working part-time. So from this picture, we have the following observations. The first one is that PVFS outperform NFS configurations over time. So I think this may be possibly because the BTIO is an I/O intensive application. And also the PVFS scales up by adding more I/O servers. The PVFS 4 I/O server configuration beats all other configurations because we have more money to rent more I/O servers. Also, part-time I/O servers provide pretty good performance. This one. The part-time I/O servers don't cost any extra money since we deployed them into the computing instances working part-time. This picture shows the total cost analysis. If you care more about the total cost, you prefer cost to performance, you can see this picture. The cost calculation is the formula, the number of computing instances plus multiply the run time, and here is the price per second. From this picture, we have the many interesting observations, but due to the time limitation, I will just show that the PVFS 4 I/O working part-time is the most cost-effective. More details can be found in our paper. Okay, the last one is the proper parallel ocean program. This picture shows that the NFS server beats all PVFS I/O configurations because the POP has a very different I/O access patterns from the POP and the BTIO. From this picture, we can find that the NFS is enough, and if we want to increase the number of PVFS I/O servers, it does nothing. And due to the small message communication, the total performance is downgrade. Okay, conclude the work. This is our user work. Since we found it's very interesting to configure the IoT system in the cloud, we think it may be possible and very challenging and very useful to configure the IoT system for HPC application automatically. Since the scientists, all the domain experts don't have any experience in the computing IoT system configuration. This is the HPC application. This is the HPC application, and we using the analyzing IO patterns routine to to extract the IO patterns here and to know the IO demands. And since we have explored those IO storage options, we can combine them or mapping them using a model and to generate and optimize the configuration. So here is the final IO configuration we can provide to those scientists. So they will not hesitate to migrate those applications from the traditional HPC facilities to the cloud. Okay, this is the conclusion. The cloud enables users to build a pro application IO system, and our preliminary results hint that the HPC application behaves very differently if we give them the different IO configurations. But the IO configurations depends on its IO access pattern. And the concurrency, we have no one size fits all configuration. There is no silver bullet. And there is also a cost and efficiency trade-off. Okay, that's all. Thank you.
Okay. Any questions?
I'm from EMC. This result is very interesting. Can we go back to the performance? Yeah, whenever you measure the EBS performance, do you have any QoS guarantee of the performance from that storage?
The QoS, quality of service?
Yeah. Because that's from the third parties, right? You do not have the full control.
Yes.
How can you guarantee the quality service from there?
Okay, I've got it. Okay, thank you. This question is very interesting because as we did our experiments, we did experience the shutdown of the EBS service. So all of our data are lost, and we have called the service hotline, and they told me that they have many measures and redundancy disks, so they can recover it for us. But it cost about 3 weeks to about 1 month. Yes, the EBS disks have low availability than ephemeral disks. And also we have, I want to mention that there is a very high variance of the performance of the EBS disk. Yes, very high. And then, but the ephemeral disks keeps stable. Okay, thank you.
Okay, no more question. Let's switch to the next.
Okay, thank you.